Okay, this question we have two cars travel in the same direction along a straight highway. One's at a constant speed 55, 60 miles per hour. The other one's going 60 miles per hour. Assuming, okay, they're both starting at the same place, how much faster does the faster car, or how much sooner does the faster car arrive at their destination 14 miles away? And so, if they're both going 14 miles, we just want to know the difference in time. So we could use d is equal to v over t, v times t, if our distance is 14 miles and our velocity is 60 miles per hour, and time is that. Just use time is equal to d over v. Just divide them, right? So 14, he gets there in 0.23 hours. Okay, the other guy's going to be 55 divided by. Yeah, I'm going to try to be better with my equations. I feel like I'm really lazy when it comes to it. I feel like I remember it, but I don't be remembering it. Okay, so the total miles is that, and then he's going 55 miles per hour. So just divide those two. Yeah, so what are you gonna get? You're gonna get 0.25 hours, which makes sense, right? He's gonna be a little bit slower. So how much sooner? It's gonna be, yeah, 0.25, sorry. How much sooner? Just subtract it, right? 0.23 hours. He's gonna take 0.02 hours more. That's really it. Okay, so now we're part B. So this is, I would say, it's one of the more confusing parts because it's kind of an intuitive question. So it's asking how far must the faster car travel before it has a 15-minute lead on the slower car. And so let's just write down what we have, right? 60 miles per hour. We can just put mph. And he's going 55 miles per hour. So if there's a 15-minute, how far must the car travel before the 15-minute lead on the slower car? So I wrote that right here, 15-minute lead. Okay, so just to understand, the 15-minute lead is equal to the distance traveled by the slower car during that time. And so to find the distance, we're going to use the 15 minutes that passed and how fast the car is going. And so the first part is we're going to do the equation I know times t. If the time is 15 minutes, which is 0.25 hours, and the time is how long? 15 minutes, so the velocity is 55, then we know that this car has traveled 13.75 miles. Okay, so now that we know that the car in 15 minutes travels 13.75 miles, we want to know how far does, how far does, we want to know how long does the faster car take to get that time. And so we're going to do the next equation. So this is one, this is two. Okay, so what are the numbers we have? The time. So we're going to get time is equal to over velocity was equal to the change in displacement, 13.75. And so this is the more confusing part because what velocity do you use? Um, to do that, you're going to use something called the relative velocity. And so relative velocity is 60 minus 55. So his is 55 miles per hour. So 13.75 divided by 5, that's going to be 2.75 hours. And so now that we found that, now we could just use all the numbers that we already had before. So x is equal to v over t. If x is that, then 2.75 is the hours we have, and then he's going 60 miles per hour. So the answer is going to be 165. So just to reiterate, since he's a 15-minute lead, he has a 15-minute lead. And so 15-minute lead is equal to the distance traveled by the slower car. That's why we found this. And so we're going to take that number from that car, we're going to put it here, and then we're going to see if this car is a 5 mile per hour, like how much is going more, like how faster it's going. Since we know that the faster car is going 5 miles per hour more, we want to plug that into this equation, and then we're going to get that for the time. That's how fast, that's how far it's going to go in that time. And then you're going to plug all those numbers you have into the real equation. I hope that helped. Let me know if you have any questions.